Section 9.6 is the quadratic formula and discriminant. I can solve quadratic equations using the quadratic formula, and I can find the number of solutions of a quadratic equation. Those are our learning targets and what we're shooting for here today. Big ideas for this section. Any quadratic equation can be solved using the quadratic formula, and the discriminant of a quadratic equation can be used to determine the number of solutions an equation has. Take note, on page 582 is the quadratic formula. This is going to be very helpful for you to have. Guys, I have a couple different videos here. These two are actually the same. We watched these in class for those of you that were here. But this one you can find by Googling or searching on YouTube, Quadratic and Pop Goes the Weasel. I believe, and this one is Mr. Boardman again, and he walks us through the steps to complete the square on our standard form quadratic equation to get to the quadratic formula. And this you can watch by searching quadratic and payphone. And those are two different ways to get this quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a to stay in your noggin. So the Pop Goes a Weasel is usually the way that I use here. So whenever I use a quadratic formula, I sing the quadratic formula song in my noggin to the tune of Pop Goes a Weasel. So that's how you find those guys if you're looking for them to try and help memorize the formula. Okay, so in example 1, we're going to use the quadratic formula. And just like when we solved before, I want to get it set equal to 0 and in standard form. So x squared minus 2x minus 8 equals 0. Standard form. Now we're going to pick out what our a value is, our b value, and our c value. Our a value is always the number in front of our x squared. Here it's a 1. Our b is always in front of our x. Here it's a negative 2. And our c value is always our constant. Here, negative 8. Remember, our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2 times a. When we plug these in, guys, that's like our framework. That part stays every single time. And now we plug in our values. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. What I would recommend doing, guys, is to simplify from here. So minus a negative gives me a positive 2. 2 times 1 is also positive 2. And I would simplify what's inside of our radical. I want the exact answer here, guys. So negative 2 squared is 4. Negative 4 times 1 times negative 8 gives me a positive 32. So I get a 36 here. And that's what goes inside my square root. Now, we know that the square root of 36 is 6. So we can reduce this further. And then from here, our two answers are going to be 2 plus 6 divided by 2 and 2 minus 6 divided by 2. One's plus, one's minus. So 2 plus 6, let me change colors here. 2 plus 6 is 8 divided by 2, which gives me 4. 2 minus 6, negative 4 divided by 2 gives me negative 2. So 4 and negative 2 are my solutions. We also could have done this by factoring here, guys, but we wanted to get practice with that quadratic formula. To check your answers, plug them back in, and they should work. So here I have 4 squared 16 minus 8 is 8, which is the same as 2 times 4. That checks. Negative 2 squared is 4 minus 8 is negative 4, which is the same as I get if I take 2 times negative 2. So that checks as well. Feel free to pause here and give this a try if you'd like. First thing we're going to do is get it set equal to 0 and in standard form. So x squared minus 4x minus 21 equals 0. We're going to pick out our values, so a, b, and c. A, 1, b, negative 4, c, negative 21. Remember here that if there's not a number in front of a variable, it's a 1, and that our signs go with our numbers. Now, our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And so we plug in our values. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And again, we're going to simplify this a little bit first. So I'm going to simplify what's underneath my square root. Negative 4 squared is positive 16. Again, when we square a number, guys, it's always going to be positive. Take your sign with your number there. So negative 4 times 1 times negative 21 gives me a positive 84. So now I add those up and get 100. And that's what goes inside my square root. So minus a negative here gives me a positive 4 plus or minus the square root of 100 divided by 2. And we can reduce this further because we know what the square root of 100 is. Square root of 100 is 10. And from here, I'm going to split up my answer. So 4 plus 10, all of that divided by 2. And 4 minus 10, all of that divided by 2. 4 plus 10, 14 divided by 2, which is 7. And 4 minus 10, negative 6 divided by 2, negative 3. So my two answers there are 7 and negative 3. In example 2, we're going to find approximate solutions. In the shot put, an athlete throws a heavy metal ball through the air. The arc of the ball can be found by the equation here, where x is the horizontal distance in meters from the athlete and y is the height in meters of the ball. How far from the athlete will the ball land? So here, we want to know when the ball lands, which means its height now will be 0. Okay, when it lands on the ground, we can see that in the picture on page 584. It has a little bit of a drawing there, so the shot would continue and hit the ground, okay, when it lands, so our height will be 0. So 0 equals negative 0.04x squared plus 0.84x plus 2. Now, here we're going to use the quadratic formula. A is the number in front of my x squared. B is the number in front of my x, my linear term there. And C is my constant. Quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And again, I'm going to reduce here if I can. And negative 0.08. Inside my square root, I'm going to simplify here. 0.84 squared is 0.7056. And then don't forget we take the sign with our number there. So negative 4 times negative 0.04 times 2 is going to give us positive 0.32. So when we add those together, I'm going to get 1.0256. And when I take the square root of that, guys, I get a decimal here. So this is not a perfect square. So this is going to be approximate values that we get. So again, we're going to do this the same way as we did before. We're going to add on top. So negative 0.84 plus square root of 1.0256. I would press enter there or put it in parentheses and then divide by negative 0.08. So here I'm going to get negative 2.16. And then when I do the minus, negative 0.84 minus our square root of 1.0256. And then divide by negative 0.08. I get 23.16. And keep in mind here, guys, we're talking meters. So if we look at this, do our answers seem reasonable? Do they make sense? No. We can't have negative meters here, guys. So how far from the athlete will the ball land? About 23.16 meters, which is a pretty decent throw there. Now, a batter strikes a baseball. Our equation here models its path, where x is the horizontal distance in feet the ball travels and y is the height in feet of the ball. How far from the batter will the ball land? Round to the nearest foot. So again, when it lands, that means my height is 0. So I'm going to plug a 0 in for y. Pick up my values. A B, and C. Quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. I'm going to reduce where I can. So inside my square root here, 0.7 squared is going to give me 0.49. And again, take your signs with your numbers. So negative 4 times negative 0.005 times 3.5 is going to give me 0.007. So when I add those together, I get 0.56. Again, that is not a perfect square. So as simple as I can get this here, and when I multiply in my denominator here, I want to simplify that as well, I get negative 0.01. Now we're going to find our approximate values. So again, I would encourage you to type in your numerator, press enter, and then divide, or put parentheses there. So negative 0.7 plus square root of 0.56, and then divide. It's going to give me approximately negative 4.83 feet, or to the nearest foot, approximately negative 5 feet, which we can't have negative feet. If I do the plus there, negative 0.7, or sorry, the minus, negative 0.7 minus the square root of 0.56, and then divide by negative 0.01, I'm going to get approximately 144.8, which rounds up to 145 feet. So the baseball will land approximately, when we round to the nearest foot there, 145 feet away. On page 584 in your book on the bottom, it talks about when to use each type of method here. So some things we've done, guys, is graphing. And that's if we have a graphing calculator or a graph already. Otherwise, it might not be our fastest method. Square roots is when there's no x squared terms. Factoring is if it's easily factorable, usually if our coefficient is 1. We complete the square if our coefficient on our x squared is 1, but it's not factorable. And then we use the quadratic equation anytime that it's not easily factorable or that we can't factor it. So if there's no x squared or x term here, guys, okay, I have no x term, that means I'm going to use square roots to solve this. So when there's no x term, just an x squared, we use square roots. In B here, my coefficient is a 1, which means we're either going to try factoring or completing the square. We can multiply to 30 and subtract to 1 with 5 and 6. So here, we're going to use factoring. And that's anytime a is 1. So my coefficient on my x squared is 1. We're going to try factoring, and if not, we'll complete the square. On C, here I have an a value. So rather than trying to swing here, I'm going to go right to the quadratic formula. So anytime we have an a value that is not 1, I'm going to use the quadratic formula. In D here, my a value is 1, and I have an x squared term. So we're going to look for factoring, and if we can't factor, we're going to complete the square. So to multiply to 3 and add to 5, we can't do. So we can't factor, so here complete the square. I'd also take quadratic formula on that one. And in E, I have a number in front of my x squared, which means I'm going to go right to our quadratic formula. So anytime a is not 1, so we have a number in front of that x squared, we're going to go right to the quadratic formula. So here you go ahead and try these if you'd like. On A, the number in front of my x squared is a 1. So we're going to look to factor. If we can't factor, we're going to go to complete the square. So I want to multiply to 12 and add to 8, 6, and 2. So here we would solve by factoring and zero product property. In B, I have an x squared term, but I have no x term, no linear term. So here, I would use square roots. And in C here, I have that 5 in front of my x squared, which means I'm going to go right to my quadratic formula. Guys, you can use multiple methods to solve these. These are just the most convenient usually. And it depends on your preference, but these are the type of things that I'm looking for here on this one.